yesterday we talked about x squared, and we said we couldn't. What was true about x squared? It wasn't what? Didn't pass the horizontal line test. It's not 1 to 1. And in order to find the inverse, it has to be 1 to 1. But on this problem, what am I telling you?
It's greater than 0.
I'm only taking half of this parabola. I'm only looking at the positive side. So if you only take that, is it 1 to 1?
Yes.
Yes. So we can do that. So to find our inverse, first step, you have to write it as y equals. Then what do we do?
Switch to minor.
And then?
Switch to echo.
Before that? Solve for y. Get the y by itself. So square root. With a square root, we always add a plus and minus, but I don't need that in this problem. Why? I've already told you we're leaving it the positive. So y is just the square root of x, and then we write it as f inverse of x equals the square root of x. Okay, I've asked for domain and range of both the function and the inverse. Domain of the original function, I gave it to you in the problem. I said that x was greater than or equal to 0, so how would we write that?
0.
Because it's equal to, we'll do a bracket, 0 comma infinity. And I know the domain of the function is the same as range of the inverse. Okay, instead of trying to figure out the range of the original, let's just look at the domain of the inverse. It's a square root. We know that if you have a square root, whatever's underneath has to be positive. So the domain of this one is also going to be bracket 0 comma infinity, which means the range of my original function is the same. Let's do another inverse problem just to make sure we've got it. Do one of the uglier ones. So if I gave you x plus 5 over x minus 3. First step to the inverse is?
Right as y axis.
Second step?
Switch to
Solve for y. So because it's a fraction, I'm going to multiply by my denominator. So that gives me xy minus 3x equals y plus 5. Then what? We need everything with a y on one side and everything without on the other. So I'm going to subtract over this y and add over my 3x. Then both of these terms have a y, so we take the y out, and that would leave us with x minus 1. So we get 5 plus 3x over x minus 1. So final step, we write f inverse of x. It's 5 plus 3x over x minus 1. Domains and ranges. For the original function, It was a fraction. You know, if we have a fraction, the bottom can't be 0. So what could x naught be? 3. So we would write that as negative infinity to 3 union 3 to infinity. And that is the same as let's go to the inverse. What can x naught be? So the domain of that would be negative infinity to 1 union 1 to infinity, which would be the same as the range of the function. Domain of the inverse and the range of the function are identical. Any questions about finding the inverses? The last two examples are really just trying to make sure we understand the idea of an inverse. It says, suppose f of x is the number of cars that can be built for x dollars. What does f inverse of 1,000 represent? So if we think about the original, we know the order pair is x, y. What does x represent? Dollars. What does y represent? The number of cars. Okay, so for the original, we're talking about function f. The order pairs represent dollars and cars. So when you think about the inverse, those order pairs flip, so the x value represents the number of cars, and the y represents dollars. So when I say f inverse of 1,000, the 1,000 is like the x value in the inverse. So the x value in the inverse is the number of cars. This whole thing represents the y of the inverse, which is dollars. So f inverse of 1,000 so that total inverse represents your cost or your dollars to build the 1,000 cars. Does that make sense to everybody? Just take time to think about what x and y represent, and know in the inverse they just flip roles. So the 1,000 has to be the number of cars, and we are looking for the dollars. So we're looking for the total cost for the $1,000 or 1,000 cars. Yes, ma'am. Yes. So in the original, f of x, that's like your y is your number of cars, and x is the dollars or the cost to make those. So this whole thing, when you see that function notation, that's like talking about a y value in the inverse. So the y value in the inverse is the same as what x was in the original. So it's our dollars or the total cost. Other questions? Last one. There's going to be one like this on the Math Excel. This is the graph of the function. If you look, I'm asking you questions about the inverse. Okay, so if I want f inverse of 2, I'm looking for the y value in the inverse. This 2 represents the x in the inverse. So what is it in the original function? The y. So what this means is in our graph, y equals 2. Okay, because this is the graph of the function, and I'm asking you about the inverse. So if 2 is the x in the inverse, it's the y in the original. So if I go to my graph, when my y value is 2, what's the x? 0. So I'm just looking for that. Take a second and see if you can figure out b and c, and then we'll check it together. So 3, that means on my graph I'm looking for where the y value is 3. 2, 3, so that would be about right here, and the x value is 7. F inverse of 9, so I'm looking at my graph when my y is 9. And what's our x value there? 9. We do okay with that? So, you have the rest of class to work on the Math Excel. It is due by the end of the day tomorrow.